Because they have to lift it out of the trash.
Okay, go back. Let it go.
Yeah. Oh, it fell on me. There's a cold bit right. That's not the cold.
Take a picture
That
before
is
it sinks.
Jinx! Oh my god.
Seeing here is a piece of superconductor that is levitating above a set of magnets that are put down on a table. And so the magnets are oriented, let's say, so that their north pole points up. And so you have these field lines that will be pointing in this direction. Now let's suppose that superconductor starts to drop if it tries to fall because of gravity toward the magnet. What will happen is as that superconductor falls, there would be an increase in upward flux through the superconductor unless it takes action to avoid that. And so what will happen is it will fight that change in upward flux by running current to generate its own downward flux in order to keep the net flux through it constant. So current will run to try to oppose that increase in upward flux. And so then what happens is you effectively turn the superconductor itself into a magnet because there's currents running through it. And you now have a north pole facing the north poles of the magnets that are underneath it. And so the net result is the superconductor, which is at first attempting to fall, is repelled from the magnets below, so it cannot fall. Well, you could also imagine that maybe the superconductor tries to fly away from these magnets. So again, you have these magnets oriented with the north pole up, and so the field lines point up. Let's suppose the superconductor starts to rise, or it tries to kind of fly away. Well, as it tries to fly away, that would be a decrease in the upward flux. You would have less magnetic field punching through this superconductor if you tried to pull it away. And so it will fight that decrease in upward flux by making its own upward flux by running a current in the opposite direction to what we saw before. Well, what that's going to do while that current is running is that's going to basically turn the superconductor into a magnet with a south pole oriented toward the bottom of the superconductor and a north pole toward the top. That will lead to a net attraction between the superconductor and the magnets below. And so that means that the superconductor, if it tries to rise, it's just going to be attracted to the magnets below. So it therefore becomes dynamically balanced. If it tries to fall, the magnets below it will repel the superconductor. If it tries to rise, the magnets below will attract it. And so it ends up being held in place and can levitate.
We'll move with
Go for
it,
it.
correct?
Yeah, we'll move with it.
Yeah.
Try to like
Oh, that
touch it
looks
with
great.
the top stick.
You can see it going.
Oh yeah, that's so cool.
Try and spin it.
Yeah, try to spin.
Oh, no.
Don't touch the thing.
Wow.
Go back.
It's calming down. It's gonna drop. It's gonna drop. It's gonna drop. No, it's alright.